In the last video, you guys saw n is equal to n naught e power minus lambda t, correct? Now that lambda, what we call as the disintegration constant, it's a very important factor. Let's try to understand what is that disintegration factor. Okay, now to understand that, what we do, see, in the formula, you have n is equal to n naught e power minus lambda t, correct? Now, t is the time. Time is something what we can control. In the sense, you start the watch, you stop the watch in this time interval. So, time is in our control. N naught and n, that is not in our control. And also lambda is not in our control. So, since the controllable parameter is time t, we try to understand what is this value of lambda with respect to time. And of course, with respect to the number of atoms present in the substance. Fair enough? So, time is what we control. So, what we do, we take t is equal to 1 by lambda. Assume whatever that value of lambda is, we'll take t is equal to 1 by lambda. Now, the formula becomes n is equal to n naught e to the power of minus lambda t. That's the formula. N is equal to n naught e power minus lambda into 1 by lambda. Correct? So, cancel off the lambda. So, you have n is equal to n naught into e to the power minus 1, or n is equal to n naught divided by e, or n is equal to 0.368 into n naught, because e value is constant, right? Or n is equal to 36.8% n naught. Now, we can define what is the disintegration constant. In the sense, see, your n value is 36.8, around 37, take 37. Your n value is 37% that of n naught, correct? That means if you have, let's say, 100 atoms in the beginning in the sample, after some time t, suppose if you have 37 atoms which are still radioactive, that means n value is 37, correct? Now, what is the time frame we are looking at? That basically is what we call as the disintegration constant. That means you have to reciprocate it. In the sense, let me give you a simple example. Say you had 100 atoms in the beginning. Okay. After, let's say, 20 seconds, it comes down to 37%. Okay. You know it's 37%. So, how much of time did you take? 20 seconds. Reciprocate 1 by 20, or that whatever we are taking, right, whatever that value you have, that becomes the disintegration constant for this particular material. Because what did we take? T is equal to 1 by lambda. Lambda is 1 by t, right? So, 1 by 20, 1 by 20, 0.05. That is going to be the disintegration constant. Fair enough? So, formally if you have to define, see, this is the definition, or in layman terms if you have to tell, how much of atoms, the radioactive atoms, are remaining in the sample, and that should be 1 by E times the total number of atoms present in the sample in the beginning. This is basically the disintegration constant. Now that you have understood the example also, time becomes important, correct? So, the SI unit for lambda is either per second, per minute, per hour, or even per year. For uranium and all those things, it will go on for per years. Fair enough? This is what we call as disintegration constant.